All right. Hello, my 12 subscribers, and whoever else might be listening. This is Objective 2.5, where we're going to say I can use slope criteria for parallel and perpendicular lines. So, still working with parallel lines, which has been similar to 2.3 and 2.4. Now adding in something about perpendicular lines and using slope to determine parallel and perpendicular lines instead of using transversals and angle measures. So kind of the same idea, but again, different, just seeing it in a different way. So lots of important vocab this lesson, lots of blasts from the past, especially going on with slope. So slope, what is that even? That is a constant rate of change. So like a rate is when we're comparing one thing to another, and if one thing is changing at a constant pace in relationship to another thing, like I think of speed a lot, like 60 miles per hour, you're traveling 60 miles per every 1 hour. That's an example of slope. It's a constant rate of change. Okay, slope-intercept form is a way we organize information about a linear function. So it's just organizing that information using the equation y equals mx plus b, where m is our slope, x and y are inputs and outputs into the function, and then b is the starting point, or the y-intercept. Rise over run is a way that we can find slope. So that's when we're like on a graph, and let's say we are organizing an input and output of the linear function on a coordinate plane, and then to find that rate, we can find how y is changing by counting the units that it takes to get from one point to the other. So that's like the rise, right? So if I'm counting, I know there's no like grids here, but let's say I'm using this to kind of count 2 units. So my rise here is plus 2. Then my run is the change between the x coordinates. So where are they on the x-axis? How far away are they? If I count the run, let's say it's 3, and it went in the negative direction. So then my slope, my rise over run is negative 2 over 3. We can also use a formula to find the same information. So instead of counting boxes to figure out like what's the difference between the x and y coordinates, we can subtract to find the difference between the y coordinates, so y2 minus y1 and x2 minus x1. Okay, so basically like 3 ways of representing the same pieces of information, right? So like here in an equation, here on a graph, and then here using a formula. Opposite. That means positive versus negative in math land. So when the signs are different. So positive versus negative. Reciprocal is going to come up today. That is when we have a number and then we flip the numerator and the denominator. So a over b versus b over a. Or like 2 versus 1 over 2. Because remember, 2 you can place over 1. Intersecting is when 2 lines meet at a point. And then coordinate points is like a spot on the coordinate plane where we use, the x and y coordinate pair to describe where the point is on the coordinate plane. Okay? So, in class, again, we're talking about civil engineering, and we were talking about like, okay, if we're trying to design a map of roads and we want to make sure that the roads are intersecting in certain ways, particularly being parallel and perpendicular, we kind of explored how we could use the equations of these lines now that they're on a coordinate plane versus the angles that the lines form to like see if lines are parallel. And what we discovered when we did that in class is that parallel lines, and again, these are lines that never intersect. Parallel lines have the same slope and different y-intercepts. Which like makes sense, right? If I have 2 lines and I want them to never intersect, I want them to lean the exact same way, like my pen and my pencil. If slope shows how the line leans, right? They better lean in the exact same way. So their slope, their rise, and their run as you like go from one point on like the pencil or pen to another, should be the same. So, but they have to have different y-intercepts, otherwise they're going to be the exact same line. So an example of this would be like y equals ax plus b. That would be parallel to y equals ax. So I'm just using an a to say that like these two values where we put slope in the equation like have to be the same number plus, I don't know, c. Okay, to make sure that those are different. So that's saying again, same slope, so same value here, but different y-intercepts. So the numbers there got to be, sorry, you can't see. The numbers there and there have to be different. Okay? So let's look at this example. This asks, is line A parallel to line B? Well, they look parallel, but let's actually, they're on a coordinate plane, so let's be sure by finding the slopes. So I'm going to look at the some points on the line. I'm going to pick points that would be integers. For line A, these 2 points are already given to me. So to find the slope, let me count the rise over the run. So what would it take me to get from this point to that point? It would take me going up 2 and then to the right 1. So that slope for line A, M, is going to be a positive 2 over 1. That's the way the line is like leaning. Going up 2 and then to the right 1. Let's see what's going on with line B. Line B, let me pick 2 points. Okay, these 2 points are already given. Okay, what does it take me to get up from this point to this point? The rise is up 2. The run is right 1. So M equals 2 over 1 again. So, hey look, they have the same slope. So are they parallel? Yup, because these slopes are the same. And then let's make sure we talk about the y-intercepts. And the y-intercepts they're different, right? Yeah, we can tell because one line is higher than the other on the plane, right? This y-intercept is at 6. This one's at what? -4, it looks like. So, and the y-intercepts are different. Cool. So we know these lines are parallel. Let's talk about perpendicular. Perpendicular is lines that intersect at a 90-degree angle. Now, perpendicular lines, they're going to have different slopes, right? Like perpendicular, if we want them to intersect, so they can't have the same exact slope. They have to have different slopes, but there's like a cool pattern that shows up when slopes are perpendicular, when they meet at that 90-degree angle. It is that perpendicular lines will always have the opposite and reciprocal slope. So remember, opposite is that positive versus that negative. So one slope will be positive, one slope will be negative. And reciprocal is when we take the fraction and flip it. Okay, so both of these will be happening with the slopes if the lines are going to be perpendicular and meet at that 90-degree angle. So an example of that using just a bunch of variables is like if I have y equals a over d plus b. Let's write me a perpendicular equation. That would be, I could do y equals, now I have to make the slope opposite. So this is positive, so this would be negative. And then I have to reciprocal, so a over d would become d over a x. And then plus b. Notice I used the same y-intercept. That's cool. That doesn't matter because the slopes are different. It's okay if they have the same y-intercept. Okay, so let's look at this example and decide, is line A perpendicular? Oh, this is the perpendicular symbol, by the way. Let's write that above perpendicular. That means perpendicular. So is line A perpendicular? So line B is what that's asking. Well, let's find the slopes again. I mean, it kind of looks like it, but we're on a coordinate plane, so I can use the slopes to like really make sure. So let me pick 2 perfect points, or 2 points, sorry, that are integers. I see this one and this one. Okay, so what's my rise over my run? So My rise is 1, 2, 3, 4, positive direction, and then to the left 1, so that's negative. So my slope for line A is negative 4 over 1, or 4 over negative 1. It doesn't matter where you assign the negative sign. Okay. Yeah. In this case, sorry, I counted up and then went to the left 1. So that'd be like 4 over negative 1. You could also go down 4, which would be negative 4, and to the right 1. In both cases, you'd end up with like a negative number. Okay. And then line B, let's pick 2 perfect points. I see 1 there. I see 1 there. Those points land at integers, right? They hit the corner of the coordinate plane. Okay. So I'm going to go up 1, and then 1, 2, 3, 4. So up 1, and then to the right 4. So that rise over the run is 1 over 4. That's how that line leads. Okay. So now I'm wondering if they're perpendicular. Well, I got to do like, it's almost like check boxes. Like, are they opposite? Negative and positive? Yes, they are. They're both opposite. And are they reciprocal? Well, 4 over 1 is 1 over 4. Yup. So meets both of these criteria. So the answer is yes, because the slopes are the opposite and not reciprocal. Cool. Okay. So now we're going to flip to, so there's a bunch of practice here, a lot of really good practice we were doing in class. We're going to flip to the last key points box though, where what's happening in this points box is we're going to find parallel and perpendicular equations given coordinate points. So, for example, we're going to find the equation of a line that's parallel to y equals 3x plus 5 and passes through the point G, 6, 11. Okay, so let's remind ourselves what's up with parallel and perpendicular lines. Equations of parallel lines have the same slope and different y-intercepts. Equations of perpendicular lines have the opposite and reciprocal slope. Okay? So let's go back to this example. So if I'm finding the equation of a line, so the equation of a line is y equals mx plus b. So that's my goal, right? Y equals mx plus b. Right? And I want an equation of a line that's parallel to this line. So I'm passing through this point, right? So let me imagine what I know about this new line. Something that I do know is it has to be parallel to y equals mx plus b. So the parallel slope would equal, it has to be parallel to the line we gave, 3x plus 5. So again, equations of parallel lines would have to have the same slope. So the slope of the line I'm given is 3. The parallel slope is also going to be 3. So I know at least this will be true about the equation of the parallel of a line that's parallel to this. It will be 3x plus b, right? Or I know that at least the slope will be 3. Let me make it clear like that. So, sorry, when I go to build this equation, now I know that it's going to be y equals 3x plus b. So if I had a graph, I could like plot that on the coordinate plane. I could start with the point 6, 11, right? And then do a rise over a run of 3 over 1. I'm going to show you how to do it without having to graph though here. So what you could do without graphing is look, I want this line to pass through 6 and 11. So that means 6 and 11 are coordinates on this line. So for this line, I know x equals 6 and y equals 11 from the 6 and 11 up here. So that means these are coordinates on the line. When I plug those in, that's going to allow me to solve for what is the y-intercept, right? Which will have to be some number that's different. So I'm just going to do the math and solve for the y-intercept now. So 6 times 3 is 18 plus b equals 11. Subtract 18, subtract 18. Negative 7 is equal to b for this line. So the line is y equals 3x minus 7. That is the line that will be parallel to y equals 3x plus 5 and will pass through the point 6, 11. It'll be at this spot on the coordinate plane. Okay? So what I did here is to find on my b, my y-intercept, I plugged in the x, y coordinate the line passes through to allow me to solve for b. Okay? Let's do example 4. Find the equation of a line that is perpendicular to y equals 3x plus 5 and passes through the point 6, 11. Okay? And again, we're doing it without a graph. So the goal is still find the equation of a line. So then I'll write y equals mx plus b. Now let's think. It's perpendicular to y equals 3x plus 5. So to be perpendicular, my perpendicular slope, remember, opposite reciprocal. So negative, and then reciprocal of 3 is 1 over 3. So I know at least this much about the equation of a line. It's going to have a slope of negative 1 over 3. Then I also know an x and a y that goes with this line. X is 6, y is 11. This is a coordinate on this line. So what I can do, again, is plug in x and y, and that's going to allow me to solve for b. So 6 times negative 1 is negative 6, then divided by 3 is negative 2, plus b equals 11. Add 2, you get 13 equals b. So the equation of this line is going to be y equals negative 1 over 3x plus 13. Okay, and again, there isn't, if you'd rather graph this, right? So if you'd rather, like, on a coordinate plane, graph the line y equals 3x plus 5. And then, you know, you don't even need to graph that line, honestly. You could just plot 6, 11 on the coordinate plane, and then use the slope, negative 1 over 3, do your rise over your run as negative 1 over 3, and then see where it crosses the y-axis, and that's how you could get your equation too if you have access to a graph. Just wanted to show you here how to do it without a graph. Okay? Hope you enjoyed that. See ya. Have a good rest of your day.